Hello student, welcome to my channel Learn Physics. Today I will be discussing the chapter 9 of class 9 Force and Laws of Motion. This is the exemplar MCQ of class 9. This video will be extremely helpful for you and this video helps you to get the full marks in physics. So let's start. Question number 1. Which of the following statement is not correct for an object moving along a straight path in an accelerated motion? Its speed keeps changing? No, it is false. Its velocity always changes? Okay. For accelerated motion, velocity always changes because acceleration is the rate of change of velocity with respect to time. Okay. Now question number 2. Okay. According to the third law of motion, action and reaction always act on the same body. No. Action and reaction acting always on two different bodies. Now B, always act on different bodies in opposite direction. Okay, this is the correct. Okay. Now question number 3. A goalkeeper in a game of football pulls his hands backward after holding the ball shot at the goal. This enables the goalkeeper to exert a larger force on the ball. No. Reduce the force exerted by the ball on his hand. Yes, because this helps the goalkeeper to take longer time to reach its velocity 0. Now P is more, that is acceleration less. Acceleration less means force equal to mass into acceleration is also less. Okay. Now question number 4. The inertia of an object tends to cause the object, look at this, to increase its speed. No. Inertia is the property by which an object always keep its state of rest or uniform motion in a straight line. Now decrease its speed. No. Resists any change in its state of motion. Okay, C is the correct option. Now question number 5. A passenger in a moving train tosses a coin which falls behind him. It means it means the motion of the train is when a coin is projected vertically upward, its velocity remains changed. As it falls behind the train, so the train is accelerated because during the flight the velocity of the train increases. That is why the coin falls behind the passenger. Okay, this is question number 6. Okay. An object of mass 2 kg is sliding with a constant velocity of 4 meter per second on a frictionless horizontal table. The force required to keep the object moving with the same velocity. Look at this, as velocity v is 4 meter per second remains same. So force acting on it, that is the mass into acceleration, that is mass into, this is the v minus u by t, as velocity remain constant. So force is equal to 0. Okay. So option B is correct. Question number 7. Rocket works on the principle of conservation of momentum. Okay. Now question number 8. A water tank filled up to two-thirds of its height is moving with a uniform speed. On sudden application of brake, the water in the tank would move backward? No. Moves forward? Yes. Moves forward. Because as the because here a retardation is produced. During retardation, water experiences the force in forward direction. That is, level of the water becomes this. Okay, understood? Now short answer type question. There are three solids made up of aluminum, steel, wood of the same shape and same volume. That is three have same volume V. Which would them have highest inertia? Look at this. Greater the mass of a body, greater is the inertia. Now mass equals to density into volume. Here volume same. Now density of steel is greater than density of aluminum and density of aluminum greater than wood. So mass of steel greater than mass of aluminum, okay, greater than mass of wood. So inertia of steel greater than inertia of aluminum greater than inertia of wood. Okay, understood? So here steel has highest inertia. Okay, understood? Now question number 10. Two balls of the same size but in different material, rubber and iron, are kept on a smooth floor moving on the train. The brakes are applied suddenly to stop the train. Will the ball start rolling? Yes. The ball start rolling in the forward direction. If so, which direction? Will they move in the same speed? Look at this here, acceleration shape as acceleration shape. So after certain time they acquire same velocity v equals to a into t. Okay, understood? Now question number 11. Two identical bullets are fired, one by light rifle and another by a heavy rifle with the same force. Which rifle will hurt the shoulder more and why? Look at this. During firing a bullet, the rifle gains the recoil velocity. This recoil velocity v dash equals to momentum of bullet divided by mass of the rifle. So recoil velocity is less. So recoil velocity v dash inversely proportional to the mass of the rifle. So greater the mass of the rifle, smaller the recoil velocity. So look at this. Which rifle hurt the shoulder more and why? Therefore, rifle of less mass hurt the shoulder more because it has more recoil velocity. Okay. A horse continue to apply a force in order to move the cart with a constant speed. Explain why. During motion of the cart, the force of friction acting on the wheel on the cart. To overcome this friction, a constant force must require to move in forward direction. So force required to overcome the friction applied by the horse. Okay. Now question number 13. Suppose a ball of mass m is thrown vertically upward with an initial velocity v. Its speed decreases continuously till it becomes zero. Okay. Because when a look at this, when a body projected vertically upward, acceleration due to gravity g directed in downward direction. That is why the final velocity v dash of the body finally zero. So final velocity of the body v dash becomes zero. Thereafter the ball begins to fall downward and attains a speed v. During downward motion, the acceleration acts on the body and finally gains the same velocity at the point of projection. It implies that the magnitude of initial and final momentum of the ball are same. No, 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 no. Look at this. Momentum is the vector quantity. During upward motion, the momentum is positive, but during downward motion, the momentum is negative. So, it is not the example of conservation of momentum. Conservation of momentum takes place between the collision of two bodies. During collision of two bodies, the momentum before collision is equal to momentum after collision. Okay, understood? Look at this question number 14. The velocity versus time graph. Look at this. This is the velocity. Okay, and this is the time. Time is expressed in second and velocity expressed in meter per second. Okay. A ball of mass 50 gram rolling on a concrete floor as shown in figure this graph. Okay, calculate the acceleration and force of friction of the floor on the ball. Look at this here. Initial velocity is 80 meter per second. Final velocity is 0. Time required to comes to rest. This is the 8 second. So acceleration A equal to final velocity 0. Initial velocity 80 divided by time taken. This is the 8 second. So this is the minus 10 meter per second square is the acceleration. Now you know force. Force is the mass into acceleration. So look at this. Here mass is the 50 gram. It should be converted into kg. So 50 divided by 1000 is the mass of the body, and acceleration this is the minus 10. Now this 0 and this 0 cancel out. Okay, so this is the minus 0.5 Newton is the force acting on it. The negative side implies it is the resistive force, that is frictional force. Okay, understood? Now question number 15. A truck of mass m is moved under the force F. If the truck is then loaded with an object equal to the mass of the truck, then driving force is halved. Then how does the acceleration changes? Look at this. Initially, force F is equal to mass into acceleration. Equation number 1. If the truck loaded of an object equal to the mass of the truck, that is mass becomes mm twice m. This is the capital M, sorry. So here mass is the mm twice m, and driving force this is the F by 2. Now what will be the acceleration? Suppose A dash be the acceleration. So look at this. From here we can write this is the F equal to, this is the 4m A dash. Look at this. F equal to 4m A dash, and here F equals to ma. So ma equals to 4m A dash. Therefore 4 into m A dash equal to m into a. Now m and m cancel out. Therefore A dash equals to a by 4. Therefore acceleration decreases to 1/4 of initial acceleration. Okay. Now two friends on a roller skates are standing 5 meters apart facing each other. One of them throws the ball of 2 kg towards the other, who catches it. How will this activity affect the position of the two? When the skater throws a ball to other, due to conservation of look at this, the ball gets forward momentum. Okay, the skater also gets equal momentum, thereby the person recedes from the ball. When the other skater takes the ball, he gains the momentum mv, and due to this momentum he moves backward. So they are not 5 meter apart, they are more than 5 meter apart. Okay, now question number 17. Water sprinkler used for grass lawns begins to rotate as soon as the water is supplied. Explain the principle on which it works. It works on principle of conservation of momentum. When water comes out from the sprinkler, the water gains some momentum. From conservation of linear momentum, the sprinkler also gets momentum. That is why it rotates on the ground. Okay. Now long answered question. Using second law of motion, derive the relation force and acceleration. That is we have to derive the relation force equal to mass into acceleration. Now the statement of Newton's second law of motion is the rate of change of momentum, that is delta p by delta p, is directly proportional to the force applied. Suppose a body of mass m moves with velocity u in a horizontal plane. A force F acting on it for time t. The final velocity becomes v. So initial momentum becomes mu, final momentum becomes mv. So change of momentum becomes mv minus mu. So rate of change of momentum mv minus mu by t, that is m into this is the v minus u by t. Okay, this is the mass into acceleration. Now according to Newton's second law of motion, F proportionate mass into acceleration. Okay, therefore from this relation we can write F equals to a proportionality constant k mass into acceleration. Now if F equal to 1, m equal to 1, a equal to 1, then k equal to 1. Therefore unit force produces unit acceleration of a body of unit mass. Therefore F equal to mass into acceleration is the relation between force and acceleration. Okay, understood? Now second question. A bullet of 10 grams strikes the sandbag at a speed of 10 to the power 3 meter per second and get embedded after traveling 5 centimeter. Calculate. Look at this. A bullet of mass 10 gram. Its velocity is the v equals to this is the 10 to the power 3 meter per second. It embedded with a sandbag. Okay, that is this way. Now the resistive force exerted by the sandbag on the bullet and time taken by the bullet to comes to rest. Okay, first of all, question number 2, time taken by the bullet to comes to rest. First of all, here look at this, here distance traveling, this is the 5 centimeter, so this is the 5 by 100 meter. Final velocity v equal to 0, and here initial velocity, is the 10 to the power 3 meter per second. Now from equation of motion, v square equal to u square minus 2as. Here a equal to this is the u square by 2s. Now u square means 10 to the power 3 whole square, that is this is the 10 to the power 6. Okay, and 2 into s, that is 2 into 5 by 100. This is the 1 by 10. So acceleration is the, look at this is the 10 to the power 6 and this is the 1 by 10 and this is the 1 by 10. So we get 10 to the power 7 meter per second is the acceleration. So time taken t case to, look at this, initial velocity divided by acceleration. Now what is the initial velocity? Initial velocity is the 10 to the power 3, acceleration is the 10 to the power 7, so time taken is the 10 to the power minus 4 second. Now what is the force, resistive force? Look at this, resistive force is the mass into acceleration. What is the acceleration? Look at this is the acceleration. Now mass is the 10 gram, 10 gram means 10 by this is the 1000 kg, and acceleration is the, look at this is the 10 to the power 7, so this is the 10 to the power 7. Therefore this is the, this and this cancel out, so this is the 10 to the power 5 Newton is the resistive force acting by the sandbag on the bullet. Okay, understood? Derive the unit of force using the second law of motion. Now from the second law of motion we know force proportionate rate of change of momentum, and rate of change of momentum is the mass into acceleration. So we can write F equals to this is the k into mass into acceleration. Now if F equal to 1, m equal to 1, a equal to 1, then k equal to 1. Therefore F equal to mass into acceleration. Now from this relation we can define the unit of force. The unit force, look at this, the unit force produces unit acceleration of a body of unit mass. In SI system, look at this, in SI system the unit force is Newton. That is 1 Newton force produces acceleration of 1 meter per second square of a body of mass 1 kg. Okay. Now a force of 5 Newton produces an acceleration of 8 meter per second square on a mass m1 and acceleration of 24 meter per second square on mass m2. What acceleration would the same force provide if the both masses are tied together? Now look at this. Now first of all we have to calculate mass of the first body m1 and mass of the second body m2. Now from this relation 5 Newton is the first force, so this is the mass m1 and produces acceleration 8. So from this relation what is the m1? Look at this, m1 is this is the 5 by 8. Same force produces acceleration of 24 meter per second square, so 5 equals to m2 into 24. So from this relation this is the 5 by 24. Okay. Now so total mass, look at this, m1 plus m2, this is the 5 by 24 plus this is the 5 by 8. Now here LCM is 24. So look at this is a 5 plus 15. Okay. So this is the 20 by 24. Okay. Therefore, now force is the 5 Newton. Look at this, 5 Newton force is the mass is the 20 by 24. Okay. Into acceleration. Now this and this cancel out. So this is the 4. Now this and this is the 6. Therefore, A equal to 6 meter per second square is the acceleration produced by the force. Okay. Now last question. What is momentum? Momentum is the product of mass and velocity of an object. What its SI unit? Look at this. The unit of mass is kg and unit of velocity meter per second. So this is the kg meter per second or simple Newton into second. Interpret the force in terms of momentum. Look at this. The rate of change of momentum is equal to force. Represents the following graphically. Momentum versus velocity when mass fixed. Look at this. This is the momentum and this is the velocity. Okay, this is the momentum and this is the velocity. Now here momentum, mass into velocity. So this graph becomes straight line having constant slope. Okay. Now this slope represents the mass of the body. Okay. Now momentum versus mass when velocity constant. Look at this. Look at this. This is the momentum. This is the momentum P and this is the mass. Now look at this, P equal to mass into velocity. So P, so here P proportionate M. So this is also a straight line passing through origin. And slope of this line also represents the velocity of the body. Now what is the graph between mass and velocity when momentum is constant? Look at this. This is the mass and this is the velocity. Now, so here V proportionate 1 by M. Now, look at this graph becomes a rectangular hyperbola. That is, this graph never touches the velocity axis or mass axis. Okay, understood? Many thanks for watching this video. I assure you, if you watch this, you can get full marks in physics. Please like, share and comment on this. Okay, thank you.